If we have an equation that's non-homogeneous, so if you recall, if f of x equals 0, that's a homogeneous. But if f of x does not equal 0, that's a non-homogeneous. If we are dealing with a non-homogeneous, this is complementary. That's what they call it. You could call it the homogeneous. That's what we did in the previous sections. The particular depends on this f of t, or f of x. I'm sorry. So, if f of x, we're going to deal with only three cases. Of course, that could equal anything, but we're going to deal with those three cases and three cases only. If I see f of x to be an exponential, I'll take a times that exponential, the general, find a. If I look at a polynomial of degree n, then I list the entire polynomial with x to the n plus x to the n minus 1, and the goal is to find those coefficients, which is a lot of work. If I see a sine or a cosine, automatically I take both a times the cosine plus b times the sine of the same angle. And I'm going to do an example on each. And what if I have a combination of those? Well, I'm going to do examples on those as well. Starting off with the first problem. Solve the differential equation. I noticed that there are two parts. There's the homogeneous and a particular. So y equal, the homogeneous they call it complementary, and the particular. You always find the homogeneous first. That is, you say, suppose this equal to 0, then I'm going to let y equal e to the dt, y prime is d e to the dt, and y double prime is d squared e to the dt. That would become d squared times e to the dt plus 5 e to the dt plus 4 e to the dt equals 0. Factor out an e to the dt, that would be d squared plus 5d plus 4 equals 0. E to the dt cannot equal 0. It must be that d plus 4 into d minus 1 equals 0. Oops, plus 1. So d equal a negative 4 or negative 1. So the complementary part of this turns out to be c1 e to the negative 4t plus c sub 2 e to the negative t. Now we get to the particular solution. You say, alright, well, let's see. The particular solution depends on, this is just a, because that's a general term of a constant. Well, I need two derivatives. Y prime is 0 and y double prime is 0. I plug that into the equation, so that's 0 plus 5 times 0 plus 4 times a equal 5. So a is 5/4. So since this is my particular solution, I'm going to say the solution is plus a times, or a, and a is 5/4. So that would be my solution. So the difference between the traditional, if you want to find C1 and C2, you need initial conditions. But the particular solutions, you always find the value of that, depending on which general form is it. I'll show you what that means in a minute. So this is another problem. What if I'm looking at B? Again, I do the same thing. Here I'll say y equals the particular solution plus, the complementary solution, which is the homogeneous, plus the particular. Now, the homogeneous, we set this equal to 0. We say, alright, let y equal e to the dt, y prime equal d e to the dt, y double prime equal d squared e to the dt, and we notice we have 4 d squared plus 2d plus 1 e to the dt equals 0. e to the dt cannot equal 0. It must be that 2. Oh, I made the same mistake I did last time. Again, I apologize. I copied that from the previous. So that would become 2d plus 1 squared equals 0. D equal negative 1/2. So the solution set here, or we know that the complementary solution is c1 e to the negative x over 2. Oh, I'm so stuck on t. Crap. All applications are in terms of t, so I don't know why they switched to x, but you know. Alright, and if I get to this problem here, e to the negative t plus, if you remember, c sub 2 e to the negative x over 2 times x. Now the particular solution. The particular solution, the general form of a quadratic. So that is ax squared plus bx plus c. And we use the letters to separate between the complementary and the particular. Y prime is 2ax plus b, and y double prime is 2a. Now, 4 times y prime plus 4 times y prime plus that must equal the 3x squared. What does that mean? That means I'm looking at ax squared plus the x. Okay, this is freezing up. Plus the x. That should be an x right there. Plus 8a plus b x plus the constant, that is 8a plus 4b plus c. And here what you do, you force the values to equal, meaning the number in front of the square must equal the number in front of the square. I got a. And the number in front of x, since there's no x on the right, that must be a 0, but wait, we know what that is. A is a, so that's 24 plus b equals 0. That means b is negative 24. Got it. And if I take 8a plus 4b plus c, since there's no constant there, that must be a 0, which means 8 times a, that's 24. 4 times, what is that? So one of those minus 4 of those will be 3 of those. So what is that? 3 times 24, 72. So y equal the complementary. Actually, I could fit it up there. That's okay. Yeah, I'll just fit it up there. Plus, we said this was the general solution. A was 3x squared plus b minus 24x plus 72. That would be my solution. This is the least amount of work you could do. Unless they say, list the form of the particular solution, do not evaluate the constants. If they don't do that, that's the way to go. So, if you have a linear equation of any form, there it is. What if I have an exponential? Well, the same deal. I'll say y equal the complementary, which is the homogeneous, plus the particular. Let's get the complementary out of the way. Set this equal to 0 basically. Let y equal e to the dt. And we know how that works. Y prime is d squared, is d e to the d. D e to the dt. And y double prime is d squared e to the dt. So I have d squared plus 2d plus 2 e to the dt equals 0. E to the dt cannot equal 0, so it must be d squared plus 2d plus 2 equals 0. D squared plus 2d plus, take half of the middle number, which is 1, and square it. D plus 1 squared equals negative 1. D equal negative 1 plus or minus I. So I know the particular solution is c1 e to the negative x cosine of x plus c sub 2 e to the negative x sine of x. There, that part is done. Now we get to the particular solution. The particular solution is going to equal a multiple of that, a e to the 3t. I need two derivatives. First derivative is 3a e to the 3t. Second derivative is 9a e to the 3t. Now if I plug those in, that right there, plus 2 times this, plus 2 times y, must equal 4 e to the 3t. If I factor e to the 3t, I'm looking at 4a plus 6a, that's 10a. 10a plus 2 is 12a. So, oh my god. Okay, so we know that 12a must be a 4a must be a 1/3. So there, that equals, okay, plus 1/3 e to the 3x. That would be my general solution. Oh, never mind. They did give me initial conditions. They said, okay, so we got this much. This is our general solution. But we notice that they say, if x equals 0, y equal 1. Well, 1 equal c sub 1. If you put a 0 there, that's 0. If you put a 0 there, that's 1/3. So that tells me that c1 is 1 minus 1/3, which is 2/3. Got it. And if I take a derivative, of this, well, a derivative, y prime, is actually the product rule right there. C sub 1 e to the negative x times the sine. Y prime is c sub 1 times negative c sub 1 times negative e to the negative x cosine of x minus e to the negative x sine of x plus c sub 2 times negative e to the negative x cosine of x plus e to the negative x cosine of x plus, if you bring the power down, that's just e to the 3x. And we know if you put in 0 for x, the derivative will be 0. That is c1 times negative 1, that's a 0, because sine of 0 is 0, plus c sub 2 times, that's a negative 1. I did mess up on that one. That should be a sine. So derivative of the first, negative e to the negative x times the sine of x, so that's 0 plus 1. If you put a 0 there, that's a 1. So there it is. I have 0 equal negative c sub 1, but c sub 1 is 2/3, plus c sub 2 plus 1. So I have 0 equaling 1/3 plus c sub 2, so c sub 2 is negative 1/3. So I got c sub 1 and c sub 2, plug them in and you're done. and I would say y equal c sub 1 2/3 e to the negative x times cosine of x minus 1/3 e to the negative x sine of x plus 1/3 e to the 3x. That would be my explicit solution. The author, most books, factor e to the negative x out, probably with a 3. You don't have to do any of that. The general solution will do. And if I move to the next problem, what if I see a problem with a sine or cosine? Well, let's see how this works. Y is going to equal the complementary plus the particular. The complementary first. That is the homogeneous. When z is equal to 0, that means d plus 4 squared operating on y equals 0. Y equaling 0 is useless. D equal negative 4 multiplicity 2. So we know this is y equals c sub 1 e to the negative 4x plus c sub 2 e to the negative 4x times 4. The particular solution, y particular is going to equal a the sine of x plus b the cosine of x. I need two derivatives. First derivative, a the cosine of x minus b sine of x. Second derivative, negative a the sine of x minus b the cosine of x. So if you take two derivatives, that would be those. Negative twice a sine of x minus twice b cosine of x. Plus 8 times the first derivative, 8a cosine of x minus 8 sine minus 8b sine of x. Plus 16 times the original plus 16 times a the sine of x plus 16 times b the cosine of x, and that should equal the sine of x. So if I take the coefficients with a sine, coefficients with a cosine, negative 2a minus 8b plus 16b and negative 2b plus 8a plus 16, take that back. Plus 16b here in front of a sine, that should have been 16a. Okay, so, and that equals sine of x. What is this saying? This says 8a minus 8b times x, times the sine of x plus 8a plus 14b cosine of x equals sine of x. So what this means, the number in front of the sine must equal a 1, and the number in front of the cosine must be a 0. So if I multiply this by a negative, add those, that is negative 22b equal 1. So b is negative 1 over 22. And if I take the second equation, I would say negative 8a plus 14 times 1 over 22 divided by 2, that's 7 over 11 equals 0. So negative 88a plus 7 equal 0. Negative 88a equal negative 7. A equals 7 over 88. I might have made a mistake, but it doesn't really matter. So when you get to this solution, you say plus, there's the solution. A is 7 over 88, the sine of x, and B is 1 over 22, the cosine of and that would be my, again, this is the least amount of work I could do unless the problem says list the solutions, list the form of the particular solution, do not evaluate the constants. How about this problem? If I wanted to look at this problem, well, here I will do those individually, and let's talk about that. So first I'll say y equal the complementary plus the particular. The complementary part, I would simply say, well, let this equal 0. So I'm looking at d plus 2 into d plus 1 equal to 0. Because, well, y. Operating on y. Y equals 0 is useless. D equal negative 2 and negative 1. Very good. So this is c1 e to the negative 2x plus c sub 2 e to the negative x. I did put x, not t before, right? Yeah, very good. Okay, and how about the particular? The particular has two parts, not a problem. I'll take each one individually. The particular associated with e to the 3t is a e to the 3t. I need two derivatives. Y prime is 3a. And y double prime is 9a e to the 3t. So if I take two derivatives, that's this, plus 3 times, plus 2 times, I should get e to the 3t, meaning 9 and 9, 18, 20. 20a e to the 3t must equal e to the 3t, so 20a must be 1. I know that a is 1 divided by 20. Got it. Plus, there's the solution, 1 over 20 e to the 3x. I did it again. I never learn, huh? There we go. Now, how about this part? Y particular is ax plus b. Y prime is a, y double prime is 0. So, that's 0. 3 times a plus 2 times this must equal 5x, right there. So this says 2ax plus 3a plus 2b must equal 5x. What that means, 2a must be 5, which means a is 5 halves, and 3a, 3 times 5 halves is 15 halves, plus 2b must equal, since there's no constant there, a 0, so 30 plus 4b must be a 0, 4b must be 30, and b must be 15 over 2. Got it. Plus ax plus b. A is 5 halves x plus 15 halves. That would be the least amount of work I could do. Okay, example 2, list the form of the particular solution, do not evaluate the coefficients. Alright, so we know y is going to equal the complementary plus the particular. Well, the complementary, let's start with that. Set that equal to 0. So we have d equal plus or minus 1. So we have c1 e to the x plus c sub 2 e to the negative x. Now, if I just want to list the form of the particular solution, I'll say for that, y particular should be a e to the x, but I notice e to the x is right there. So I need to modify. how do you modify? You multiply this by x, and you say the particular in this case is ax e to the x. Since that's not repeating, you just list it there, that's fine. And if I look at the general form of a quadratic, there are no constants or quadratic. That is, I already used a bx squared plus cx plus d. And if I look at a cosine, since there's no sine or cosine, plus abcd e the cosine of x f the sine of x. So the general solution, okay, second time will be a charm. The general solution is right there. And that would be it.